Hi, I'm Bashir Umar. This is my teammate Deepak Kumar. Our project title is Enhancing Network Configuration Automation in IoV using Actor-Critic reinforcement learning. IoV is an internet of vehicles where sort vehicles and communication between each other in the real time. And Actor-Critic is a reinforcement learning approach. It's one of the learning approach. Here we use two neural network, one is actor and another critic. Where actor is used to if it's an action, whether which action is to be selected, and critic is to evaluate the action whether it's right or wrong. So this is the project on definition for the title, and we'll go for aim. Our main motive is to automate the network configuration effectively using a multi-actor multi-actor agent, multi-actor critic agent using oral approach, and we also aim to increase the enhance the QoS quality of service in between the vehicles. Quality of vehicles means which compose of multiple attributes or values like data rate, power transmission, and SNR value, etc. And go for objectives. We have objective like to automate the network configuration, Actor-Critic to use two neural networks like Actor-Critic to ensure that the system is in the right way, not to out of the systems comes within the vehicles, and to also enhance the OS quality of the business requirements. And such we also has two algorithm. One is centralized and another distributed approach in multi-Actor-Critic agent algorithm.
And myself is Deepak Kumar. I have explained the centralized activity in overall workflow. And first, you have data is going collected from the Sumo simulator, and then extract the features like transmission power, cross channel power gain, and channel power gain, and to put in the IoV environment. Then IoV environment is nothing but a centralized model, and then we have put into the you have multi-agent actor critic. So you have vehicle agent 1 to vehicle agent K. That means a multi-agents, and then you have put the your vehicle agent 1 to the state info. State info is nothing but a transmission power, cross-channel power gain, and channel power gain. And then you have, according to that, you have also the actions also, because of that according to the action you have put to the states. So the actions are modulation type, data rate, and transmission power. And then the centralized activity is nothing but you have taken a 3000 samples, you have put into the one model, and then given a one training activity and actor and critic, and then you have whole model into one quality of service evaluation. Then according to the critic state, we have to find the quality of service according to the PDF packet delivery rate, end-to-end delay, and test satisfaction rate. Accordingly, you have find the reward, and then you have put into the RSU. RSU is in a global model, because of centralized you have put all the data in the global model. Accordingly, we have wait update for each model training, and then produce the output to the Sumo simulator. And then you have explain the distributed actor critic, and you have made a difference between distributed and centralized actor critic is if a centralized you have taken a 3000 samples, you have put into the one model, but in distributed actor critic you have trained the each model by one actor and critic. For example, your vehicle agent one, then your model train for model train for actor and critic for vehicle agent one, and then vehicle agent K is actor and critic model for that. The same for but small different. Actually same for a small simulator data extraction, and then I put the IO environment district actor critic, and the same input sanction power, cross channel power, and channel powers. According to the state info, put the state info, and then action is also given. Actions are modulation type on data rate, transmission power. According to the vehicle agent one, you have each vehicle, you have find the quality of service for each vehicles according to the vehicle 1 to K vehicles. Their critic state, that means actor has to find the state evaluation. According to the critic state, you evaluate evaluation data are PDR, end-to-end delay, and task satisfaction. According to the quality of service, evaluation of agent 1 is to find, and according to the reward has been put to the vehicle agent 1, and then each vehicle action you have put to the output to the Sumo simulator. That's all.
Yeah. And here the models where we have used two different approaches. One is the central and distributed using a multi-attributing agent algorithm. So first I will go with the centralized attributing training strategy. So here we have the training and policy updates where the actor and critic updates. That's basically this attributing approach is basically run on the RCU roadside unit server. So since it's centralized, we have the one RCU to calculate the rewards and enhance the rewards, which is a quality of service. So here the ROC acts as a central controller that gathers data from all the vehicles and trains a global model and shares the learning policy back with the all vehicles. So here the actor shares optimal actions, um, which is the action that uh, that to be taken when a specific things happen. So critic is to evaluate whether the action is correct. Also, once you evaluate the critic, once the critic evaluate the actions, the rewards, the quality of the QX based rewards will be calculated and generated depending upon the actions which are taken. So here mainly the data aggregation comes into the picture where the data collected from all the vehicles is captured and sent it to the RSU. Here RSU has the automatic algorithm since it's gathered the data and provide the model, global model. And then once the global model is trained and generated, it will be transferred back to all the vehicles between the vehicles so to take the correct actions and update the quality of rewards accordingly. And here distributed Actor-Critic training strategy. So here, each vehicle has to train on its own with its Actor-Critic model independently using local data. So vehicle synchronized with the global model maintain the so each vehicle should be coordinate with them to update the model. So this is how it's worked for centralized and distributed. Right? And here's the algorithm for centralized Actor-Critic algorithm. So here the central strategic algorithm has only one RSU to calculate the rewards. So here the inputs are critic network, actor network, and QoS based rewards. So output will be the enhanced quality based rewards. So here the main parameters like data rate, packet delivery, and end-to-end delivery will be evaluated depending upon the algorithm. So here we run a epoch running up to max of 400, 150, or 300 maximum. So here the sample data is extended into the RSU and the enhanced QoS reward will be the output of the algorithm. So here we use the algorithm equations like mean squared error and compute advantage of the and also we calculate the actor loss depending upon the QS reward calculated. So this and once the model is generated, we saved the model and update the model for every training and performance. So this is distributed. So since it's distributed, we for each vehicle we have to train a model and transfer the data with every vehicles to update the model. So here the centralized and distributed are same algorithm, but the little different where the each vehicle got to train on its own. Each vehicle gets its own model to, but the basic equations and the operations will be same for centralized. So here first for each state we got to complete the SINR and QA scoring is SINR and pick an actions. So after pick an actions depending upon the needs and the critic will be evaluate the actions and provide the reward. So depending upon that, the model will be updated and moved to the state of the vehicles. So for the each state of the vehicle, the reward will be.
So this output was shown by an our algorithm outputs for first is an quality ascent loss was centralized multi-gen actor critic. It is slightly increases because of each epoch is running. So for example, the previous epoch running slightly decreases, and then next is quality of series and loss for distributed multi-gen actor. It is quality of score and loss is slightly decreases according to each epoch has been running. The next is an packet delivery rate. Packet delivery rate. Next, it's in packet delivery rate. The first two figures are centralized multi-gen actor critic, and first is a multi-gen actor critic, and second a single dequien and a random baseline and distributed dequien. And then according to my algorithm, it is slightly increases for both urban and highway scenario. Next, in distributed, it is also increases for both an highway and urban scenario. And it is an end-to-end delay for centralized and multi-acting and distributed activity. It is a decreases because of a end-to-end delay is nothing but if you have one vehicle to communicate with other vehicle and that receiver vehicle also communicate with sender vehicles, it is according to the decreasing communication speed. So it is slightly decreases compared to the previous DQN and random baseline and the single DQN models. The random baseline is nothing but data is generated by randomly, and then single deacon is nothing but a locally model trained and given output. Deacon is nothing but previously single trained deacon model and base paper distributed deacon model, and then it slightly decreases for both algorithm for centralized and distributed multi-agent actor critic for both highway and urban scenario. Highway and urban scenario is nothing but highway, that means we were running the speed of vehicles by 2.29 milliseconds. In urban scenario, we were running vehicles in 8.8 milliseconds. And there's a top satisfaction rate for centralized and multi-agent actor-critic and distributed multi-agent actor-critic. And in it is slightly increases according to the previous algorithms, because task satisfaction is communication is done or not. For example, if a one, that means the communication is done. If zero, that means the communication not done. Accordingly, it mean slightly increases according to our algorithms compared to the previous algorithm.
uh, the outcome of the algorithm, here the conclusion where the probability percent that base of the oral algorithm, depending upon that, we have the use the Actor-Critic oral approach effectively to automate the IoV network configuration. So here, uh, while we use the approach, here slightly increasing quality of service between the vehicles and data rate and transmission power, end-to-end delay and packet delay ratio. And these are the four factors which increases slightly when coming up with the last approach, deep neural networks. So here, Actor-Critic RL-based approach will be more optimized, little optimized than the human. So here, we implement both centralized and distributed way. For centralized, we have used for highway and urban scenarios. So for highway, we have used a city like Madrid city, etc. For urban, we have used 9% rate or 10% rate or up to max 100% rate grid scenario. So depending upon these two scenarios, we have seen that it is little optimization in the algorithm and also the little enhancement in the quality of service between the vehicles. So these are the conclusion outcome of this approach in our paper. Thank you.